Alrighty, let's get this started. You remember what we were doing yesterday?
Mm-hmm.
All right. There's this triangle. Okay, let's say this is 20 degrees, and this is 1, 2. That'll be the square root of 5, I believe, right? Yeah. There's that one, and then we have this other triangle. This is 20, this is square root of 5, this is 1, and this is 2. And then let's say we have something like this. 20, let's say this is square root of 5, the base is 2, the height is 1. How are these triangles related? What's the word for them, if you remember?
Similar and congruent.
So are these similar or are they congruent? Now, similar means the angles are the same, okay? Not the size. Congruent means the angles and the size are the same. So which one is the similar or congruent? If you notice, I just flipped both of these, okay? The orientation is different, but do all three triangles have the same angles and the same side lengths?
No.
No, but which one is different?
The first green one.
The first green one is different? Oh yes, you're right, because it has a different base, right? Actually, does it? No, they're the same. Actually, this one and this one is the same. I just flipped it. Like I just put a mirror here and I got this, right? 1, 2, 1 root 5, sorry, 2 root 5 and 1. Yeah, I just put a mirror in the middle. That means it's just a different orientation, but the sizes are the same, right? The side lengths are the same. So all three of these triangles are congruent. Similar would be something like this, right? So you have this one, and then you have maybe this one. It doesn't necessarily have to be in the same orientation either. It can be something like this, okay?
Mm-hmm.
So let's say this is 20. Let's say this is a right angle. Let's say this is 2. Let's say this is 4. Let's say this is 3. What would be the side length here?
6.
How did you do that?
Because the scale factor is 2.
Correct. Oh, there you go. Correct. That's absolutely right. I'm going to tell you something else, which is just for extra knowledge, I guess. Whatever the area of this is, okay, let's say the area of this is 10, for example. Yeah, it's not going to be 10, whatever. The area of this is 10 because we don't know what the base length is. The area for this one, there's an easier way to find it, okay?
Mm-hmm.
If they are similar, given that the two triangles are similar, and we know it's similar because this angle is the same and they both have right angles. So these two triangles are the same. Their areas are also related. And how are they related? To find the area of the bigger triangle, you need to multiply it by the area of the smaller triangle, okay? Times the scale factor squared. Okay, the
Mm-hmm.
squared of the scale factor. So let's say the area of the smaller triangle is 10. What would be the area of the bigger triangle?
40.
Yes, and that's how the areas are related, okay?
Okay.
Let's explore these right angle triangles in a little bit more detail because this is important. This is going to be something that you're going to be doing a lot of eventually. So this is a right angle triangle, okay?
Mm-hmm.
Let's say this is some angle X. Now notice this side is opposite to that angle, right?
Mm-hmm.
The angle is here. Which side is it facing? It's facing this side. So this side here, the height of this triangle, it's called the opposite side, and we're going to label O. Okay, O for opposite.
Mm-hmm.
What's the longest side of a triangle called?
The hypotenuse.
Right, so this side is always going to be the hypotenuse. Hypotenuse is the side that's opposite to the right angle, right? So this is going to be H. And now the side that's remaining on the bottom, and it's called the adjacent side because it's adjacent to the angle. Okay, if x is there, this side is called A. Alrighty.
Mm-hmm.
All right, so now I'm going to tell you something which we have not done yet. There are something called trigonometric ratios. Okay, it just means the ratios of a triangle, of in fact a right angle triangle. It also applies to triangles that are not right angled, but let's start off with the right angled ones. There is something called the sine function. Okay, the sine function. You have this on your calculator. And what is this? This relates to the right angle triangle. Sine is equals to the opposite over the hypotenuse. Okay, sine is O over H. I know you have a button on your calculator called sine. And there's 3 of these ratios. The next one is called cos. And cos is equals to A over H. And then finally there's tan. Tan is O over A. And this is going to be the bread and butter of this unit. There's an easier way to remember this, and this is called the SOH CAH TOA rule. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Now, how does this help us? Let's do a quick problem. I'm just going to keep these on the side because we're going to need them. Actually, I'm also going to keep the diagram because the angles, the lines are nice. So let's say, this is 20 degrees, okay?
Mm-hmm.
And this is side length 3. The goal is to find the hypotenuse. Okay, the goal is to find the hypotenuse. Before we would use the Pythagoras theorem, right?
Mm-hmm.
To use Pythagoras theorem, what do you need?
Like 2 places.
Yeah, exactly. You need 2 side lengths. In this triangle, we do not have 2 side lengths, so we cannot use a squared plus b squared equals c squared. But what we do have is an angle, okay? And that will help us find the hypotenuse. Step 1, let's identify what's given. Which side length is given? Opposite, adjacent, or hypotenuse?
Opposite.
Right, so opposite O is going to be 3, okay? What are we trying to find?
H.
Trying to find the H, right? Now, which ratio uses O and H?
Sin.
Yeah, exactly. It's seen. It's pronounced. This is from the Greek word. It's pronounced sine. Okay,
Sine.
sine. Yeah, sine. And then this is cos. This is a short form of cosine, and tan is the short form of tangent. But you can just say sine, cos, and tan as you see it on your calculator. Now let's use this to find the hypotenuse. So let's set this up. Which ratio uses O and H? We just identified sine uses this. So we're going to do it like this. Okay. And by the way, all 3 of these functions, they always have an angle attached to them. Okay. Some angle. Okay. So they have some angle attached to them. So in this case, it'll be, we know we have to use sine. It'll be sine of 20. Okay. Is equals to the opposite is 3 units. And the hypotenuse is H. We're trying to find this hypotenuse. Cool. That's how you set this up. Why don't you try plugging in sine 20 on your calculator and tell me what it gives you? It's going to give you a mumbo jumbo decimal number, but that's fine because that's exactly what it is. If you plug sine 20 equals.
0.342.
Yeah, exactly. It's going to be 0.342, and that is equals to 3 over H. And there we go. Now we have a linear equation. How do you solve for H?
You multiply 3.
Nope. If you multiply 3, you'll just get a 9. It's not going to help you cancel that out on both sides.
You divide.
All right, so there's 2 ways to do this. Either one way, you can swap places with this and this. This goes there, that goes up there. Or let me show you this so you in 2 steps, you understand what's going on. You don't multiply by 3. Step 1, you multiply both sides by h. Okay? Times h, times h. And notice on the right-hand side, we killed the h. So you're just left with a 3. And on the left-hand side, you're left with h times 0.342. And now what do we do? I was just trying to solve for h.
Do you divide?
Yeah, now you divide. So now h will be equals to 3 over 0.342. Yeah? 3 divided by that. Therefore, the hypotenuse of this triangle is 8.77. Cool? And now to find the bottom side, the adjacent side, we can either use, here, let's try to not. We can either use the Pythagoras theorem, right? Or we can use something else, because now we have all the other two sides, right? Let's use this one. Let's say the opposite is 3. We're trying to look for the adjacent. Which ratio do we use? We want to find the A, right? And we're given O. Which one has O and A? Just look at these 3. One of them has O and A.
Tan.
Yeah, exactly. So look, we're going to set this up. It's going to be tan of the angle 20, okay, is equals to the opposite, which is 3, and A that's missing. Whenever the unknown is in the denominator, you have to multiply both sides by the unknown, okay? Like that. Because this is going to cancel out with this. So on the right side, we have 3. On the left side, we have A times tan 20. How do we solve this for A?
You divide.
Yeah, why don't you try dividing 3 over tan 20 and tell me what you get.
8.242.
8.242. And there we go. And we can double check this, right? And we can double check this by using Pythagoras theorem. So we know this, let's say this, well, this will be A. Let's call this B. Again, A and B in the Pythagoras theorem doesn't matter, okay? A and B does not matter, but C absolutely has to be the hypotenuse. So we have 3 squared plus, again, we're trying to see if this is right using Pythagoras theorem. B squared plus A squared equals C squared, right? How do you solve this for A?
You subtract.
Yeah, you subtract whatever that is, right? 9 from both sides, and then you can square root this. Why don't you try doing this? Square root of 8.77 squared minus 9.
It's giving like 6.03. I don't know why.
Oh, because we didn't set this up right. Or did we? Wait a sec. 6.03, let me double check. 8.77 squared minus 9. The square root of that. 3 divided by 10, 20. 8.77 squared minus 9 is 67. I got 8.24 for this, right? 8.24 using Pythagoras theorem. So you see, these two should be the same. Even if you use the trigonometric approach, the trig, let's just call it trig because it rolls off the tongue. Even if you use this approach or you use the Pythagoras theorem approach, you should get the same side lengths. Except to use Pythagoras theorem, you need at least two sides. To use any of these guys, you need one side and you need one angle. Not the right angle. This one is always going to be right angle. You just need one of the other angles.
Mm-hmm.
Okay, and there you go. That's the crux of this unit. Now we're going to see what they have for us. And this thing was invented BC. You know what BC means in terms of dates? Right now it's 2022 AD. What does that mean if you know? What does the AD here stand for? Before that, you know, there was a 0 AD, I guess. And before this, there was BC. Do you know where these come from?
Was like BC before the birth of Christ or something?
Yeah, it was. BC means before Christ and AD means after death, okay?
Mm-hmm.
And this thing was invented about 3 BC. So over 2,000 years ago, 300 years before Christ was born. You know what's funny? Well, I don't know if it's funny, but it's interesting at least. So this was invented simultaneously, which means at the same time, in civilizations that had no connection between them. They did not have a way to communicate between them, which is quite interesting. So it was invented here by the Greeks, okay? And then if you look at ancient texts in Asia, there's proof that trig existed there as well. I mean, there's proof yet. So they were both doing the same kind of math around the same period, even though they had no communication with one another, which is pretty interesting. How's that possible, right? But that's just how, I guess, the thirst for knowledge points us in a specific direction. And yeah, same thing with like music. Like they didn't know it was called the ABCD, whatever the chords, right? But they were playing the same kind of musical notes, even though they would have no means to contact one another at that time. Anyway, so let's try it. This thing was invented like 300 years before Christ. We're still using it. In fact, we use this everywhere. Like when you're building something, navigation, cars, everywhere this is used. Okay, that's a wide uses. So this girl wants to know the slope of a ski hill. So let's say this is the ski hill, okay? And this would be the slope, okay? This will be the slope. Our trail map shows that the hill makes an angle of 18 degrees with the horizontal. Horizontal just means like a horizontal line, like an x-axis. Something like this. This is the slope, okay? And this is the horizontal line. That just means the x-axis. This is 18. Is there any way to find the slope right now?
No.
No, there's not, right? I mean, if you use Pythagoras theorem, you need two sides. If you use trig, you need one angle, which we do have, and one side length, which we don't have. So there is not enough space, or there is not enough thingamajig. Actually, they don't want the side length. They just want the ratio. We are missing a side length, so I don't know what they're trying to do. But they're just trying to evaluate what this is. Okay, forget about this question. They just wanted us to put 1018 in the calculator. That's not going to help us there, but this one we can do. And these are also calculator input questions. Let's look at angle A. Angle A, 67 degrees, right? They want to find sine and cosine for A and B. So it's pretty simple, this one. Look at this. Sine of A would be sine of 67, yeah? They just want to put this in the calc. I don't know why, but I guess we'll just do it. 0.9205 is what I got. And then if you want cosine of A, that'll be cosine of 67. And again, you just plug that in a calculator. And that is 0.3907. And you do the same thing for B. It's just a calculator plug and chug. We don't have to do this. I will tell you this though. What in the world do these numbers represent? You see? They all give us a number, right? When we plug that in a calculator. I'll tell you this much, where this comes from. Because you might be intrigued, like, yeah, the numbers exist, but where in the world do they come from? Think of a circle, okay? Think of a circle that has a radius of 1 unit. I'm just gonna draw a circle right through this origin. Not a perfect circle, but doesn't matter. Important part is the radius is 1 unit, okay? And from this origin, I'm gonna draw the radius out to the circumference right there. And I'm going to make a triangle out of this, a right angled triangle. And let's say this line that I drew is at 20 degrees. Okay? Let's look at this point. We can call that x1 or x and y. We'll just call it x and y. Now, sine of 20 represents the y value of that point. And cos of 20 represents the x value of that point. So in the previous question, we had an angle of 67 or some degrees, right? And we got 0.92, whatever. Those are the coordinates of where this arm, this radius, touches the circumference. It's the x and the y point, okay? That's what it represents. I'm also gonna show you something which I probably shouldn't because I might get overwhelmed, but we're not gonna do this, but I'm just gonna show you. We've done this, right? Y equals mx plus b, or y equals x. What does the graph of y equals x looks like? Anything that is a function has a graph, okay? Y equals x. Do you remember what that looks like?
A straight line.
A straight line through the origin, that's right, right? Now we've done this one as well. Y equals x squared. What does that look like?
Was it like a curve or something?
It was like a U. Okay, that's y equals x squared. Now I don't know if you remember this one. What does y equals y cubed look like? Sorry, y equals x cubed.
I don't remember that one.
It looks like a snake. So it starts down here, like that. That's y equals x cubed. And then x4 just looks like x squared, except it's a little bit fatter around the origin. Okay, and from here, everything is the same. x5 just looks like x cubed, except it's fatter around the origin like that. So anything that's a function has a graph. And this is going to be really interesting. What do you think y equals sine x looks like? I'll give you a hint. It is periodic. That means the values, like here, none of these graphs are periodic. Sine x represents the y value, okay? And depending on what the angle is, it's going to come back. It's going to do a little loopy loop. Could you possibly imagine what does sine x look like graphically? And we won't be doing anything regarding this, but I just want to show you what, because it is really interesting. Any ideas?
Is it a circle or something?
No, it's not a circle. If it was a circle, the good point, this would not be a function, okay? To be a function, you can't, if you draw a vertical line, you can't touch the same point twice. You see, these are going to be functions because if you draw a vertical line, it doesn't touch the same thing twice. So a circle is not a function because if you draw a vertical line, it touches the graph twice. Here, let me show you what sine x looks like. And cos x is exactly the same thing as sine x with just a little bit of a difference. Ready for this? Could draw it by hand, but this is more precise. Boom. That's what sine x looks like. Goes up and down like a wave, you know? It goes on forever. Never stops. Goes on forever on both sides. Cos x looks very similar to sine x. Now sine x is the one in red. Cos x is just sine x, but it's shifted a little bit to the left. If you take the sine curve, you just shift it, you'll get the cosine curve. Okay?
Oh,
Yeah, it's the same thing as sine, except it's just shifted a little bit. Now the question is, what does tan x look like?
is it similar to that?
No, it's not. It's completely different. I'll show you what it looks like because there was no possible way of doing this or imagining this. Tan x is that one, the one in green.
Why is it like that?
Why is it like that? Because we're dividing by 0 for tan x. Tan x is equals to sine x over cosine x. Okay, this is a formula for sine x, tan x. So whenever cosine x is 0, cosine of 90 is 0. Okay, so at 90 degrees, the function tan does not exist. So tan looks like this because there is an invisible wall at every 90 degrees. See, I think this is about 90. It's about 90. It's about 90. So every 90 degrees, the function ceases to exist. There's like a wall. It hits a brick wall because we're going to be dividing by 0. So tan x has breaks in the graph. Sine and cosine, they don't. They're continuous. Like you can just draw them in one stroke. But tan x you can't because there's breaks in the graphs because we're going to be dividing by 0 periodically. Every 90 degrees, we divide by a 0.
Okay.
Okay, kind of interesting. Don't worry, we're not going to do anything like this. But that's just for you to, just to bring out the curiosity. Okay, so that's what we're working with, but we don't need to know what it looks like. We just need to be able to solve problems regarding that. Now, if you look at your calculator, there's a button directly above a sign. What does that read? Or not, no, I didn't mean a button like. There's something it says directly between the sign button. This is the sign button, yeah. There's some button here, it doesn't matter this one. It says something directly above the sign. It's not a button. There's some text
Sine
here.
-1?
Yeah, exactly. Sine -1, right? That reads sine inverse. And we're going to be using that to solve this problem. So now what does that mean? Notice in this question, the angle is missing, right? Theta. This is theta. That just means the angle. Whenever the angle is missing, instead of using sine, we'll use sine inverse or tan inverse or cosine inverse. Let's try doing this problem. Look at relative to the angle. Which two sides are given?
The opposite and the hypotenuse.
Right, so opposite is 2. Adjacent is not given, or adjacent is the x. And the hypotenuse is 5.39. Now, which one uses opposite and the hypotenuse? Sine, cosine, or tan?
Sine.
Yeah, exactly. So we are going to use the sine ratio, okay? So let's set this up. Sine of, again, we don't know what the angle is, right? And this is the Greek letter theta, okay? This thing, thingamajig. And usually in trig, because they invented it, the Greeks, or it was prominent there, they kind of have a monopoly on it in terms of the letters. You've heard of the COVID things, right? Tell me a variant, COVID variant.
Delta.
Yeah, exactly. You know what delta means? It is a Greek alphabet. Here, let me show you. You go here, again, you don't have to know any of this. You see all these letters up here. Okay, we're gonna start from right here. You see that A?
Mhm.
That's alpha, the Greek letter alpha. And then you have beta, you have gamma, okay? And this bad boy right here is delta. See that?
So it's the name of the letters?
It's just Greek letters. Like how in different, like in Chinese, you have some, you have these weekly
Mhm.
lines. Like French, you have, I don't know, I'm not that good in French. You know what I mean? Like, yeah, every language, they have letters, right? These are the Greek letters. So the COVID variants are named after Greek letters. You see pi, pi also comes from the Greek alphabet. There's sigma, tau, rho. This is called mu. This is what we use mostly in when you reference angles. You don't have to use this specific letters. You can call it x, y, but yeah, usually we use theta. And then there's this one, which sounds pretty nice. Omega. Looks like that. Okay.
Mhm.
So basically the Greek letters are the COVID variants. Anyways, this letter here is called theta. So we're going to set this up. Sine theta is equals to the opposite, right? Opposite is 2. And the hypotenuse is 5.39. The question is, how do we solve for theta here? This is how you do it, okay? Theta is going to be the sine inverse of 2 divided by 5.39. Now on your calculator on the top left, you have something called second, I think, or shift. What do you have?
Second.
Second. So what you want to do is you want to press second, you want to press sine, and that'll bring the sine inverse function. Try it.
I
Second,
did it.
sine, bracket open, 2 divided by 5.39, bracket close, equals to. And tell me what that gives.
0.37.
Is it that small? 2 divided by 5.39. Nope, it's not supposed to be that small. Did you put brackets?
I did.
Okay, let's try doing this. We just do 2 divided by 5.39 on the side. 2 divided by 5.39. And that is 0.37, right?
Mhm.
Now on your calculator, somewhere around the equals to sign on the bottom right, you have something called ANS. See if you have something. ANS means answer. It's usually on the bottom right side.
No,
You don't?
I don't.
All right, so just remember 2 divided by 5.39 was 0.37. And now you want to do second function sine 0.0. This should bring this function, okay? Second, this is one input.
Mhm. So
And
I
try,
don't have to put sign.
no, you don't, yeah, you do second function sine, which will bring
It
this.
cancels it out.
Don't do sine twice. Just do as you see it here, okay? You want to do second function sine. Press that. What does that give?
It like brings it back to normal. Could I
You
do sine and then second
try
function?
that. Try that. Maybe your calculator is the opposite. Yeah, try it.
Now it has like second on the side.
Okay, press 0.37 equals.
It doesn't do anything.
All right, can you tell me the calculator that there's a number on top below the screen, the model number? What is that?
It's like TI and then 30XA.
Okay, yeah, this count. I don't like this one because you're right. It may be a little bit flipperoo, you know, like the inputs are flipped. Okay, so you'll do, let me just open this image if it lets me. All right, so first press second function. Just press second, then press sine.
I
Okay,
did.
press 0.37 equals.
It's still 0.37.
Well, that's not gonna help us, is it? Yeah, I don't know this one. I'm not a big fan of this one. So how do we bring the sine inverse? I mean, that's the input for that.
It's like the calculator is like a little bit different than the one on the screen.
Right. Maybe I can use the online calculator, maybe. Okay, scientific. All right, there we go. Now from this one, how do I bring, let me try this. Okay, there we go. You see sine inverse, okay? Or we can do 0.37 and then we're gonna do sine inverse. There we go. You see how I did that? First press 0, I think this is how you do it on your calculator, 0.37, and then you wanna press second function sine. And see,
It's 21.715.
okay, there we go, we figured it out. So that's how you do it on your calculator. And that's the angle, okay? You can just round it up to 22 degrees. So when the angle is missing, you have to use a second function button. So now this is 22. How can we find x? Now x is the adjacent side, right? We are given, I mean, we have everything. We have O, we have H, we have the angle. We're trying to find x. Which ratio would work here?
Tan?
Yeah, actually anyone would work. Okay.
Really?
Yep. So we can do sine. Actually, you're right, because would tan work? No, sine doesn't work, but both cosine and tan would work. You could do cosine 22, yeah, is equals to the adjacent over the hypotenuse. You could either use this approach, or you could use tan 22 is equals to the opposite over the adjacent, like that.
Okay.
But if you use this, there's an unknown in the denominator, yeah? So that might be, do you remember how to, let's do it both ways. They will both give us the same value for x. How do we solve this equation for x?
You multiply both sides by x.
Yeah, good. You multiply both sides by x, and then what do you do?
You divide.
Yeah, you do 2 over tan 22, right? And that gives us 4.95, yeah? Now try doing this one. How do we solve this one for x?
You multiply.
Yeah, try it and tell me what you get. Multiply both sides by 5.39. Cos 22 minus 5.39. Just cos 22 times 5.39 on the calculator, and it should give you the same answer.
Um, 4.997.
Right. Did I plug this one right? 2 divided by tan 22. Yeah, it's okay, because the angle, the actual angle was not 22, it was like 21.7. Yeah, there's like that's why there's a little bit of a difference here.
Mm-hmm.
But no matter which one you use, you should get the same side length because it's the same triangle. Okay.
Okay.
So when the angle is missing, you want to use the second function, the inverse button. Okay, let me just close this stupid browser. Do you use, I mean, I guess you're on a Mac, right? Or an Apple. What do you use? Do you use Chrome or do you use Safari?
I use Safari.
Right. Let's try doing this one. You remember the mountain question that we kind of briefly touched upon yesterday? Like, how do you measure the height of the mountain, right? Here, check this out. You have a device called a surveyor, okay?
Mm-hmm.
That tells you the angle. And then this one you can definitely measure, right? How far you are from the base of the mountain. Yeah?
Uh-huh.
Let's say you're 100 meters. How do you find the height of the mountain?
You find the scale factor.
So that would be if we were doing using similar triangles. Now we can do this by using trig. Look at this, what's given? Adjacent is given, right?
Mm-hmm.
Opposite is missing, and we have the angle. So which one uses opposite and adjacent?
Tan.
Exactly, tan. So you see, we can just set this up. Tan 20 is equals to the opposite over the adjacent, and you multiply both sides by 100. And boom, there you go. The height of this, well, this question doesn't make sense, but it's 36.39. Okay,
Okay.
so you can just use trig to do the same problem. There's multiple ways. That's the beauty of maths, right? You here, you want to end up here. You're at point A, you want to go to point B. There's infinite ways to get there. You can do a whole loopy loop all around the world and get there, or you can go there directly. To get the same answers, there's multiple methods. Maybe not infinite, but there's a large number of methods. And what distinguishes a good mathematician from a great one is the way they go about it, right? Who is more
Mm-hmm.
efficient? Who's doing needless work? And that's what, yeah, that makes the difference. And all these methods are being improved, right? Every day. Not this specific section, but there's entire like branches of math that just stems from SOH CAH TOA. Just from those three ratios, it goes way beyond that. It has multiple uses, okay? So I know they invented this 23 years ago, but it's being, there's evolutions in maths, right? And like we saw with the curve, and it goes way beyond that as well. We're not gonna touch, we're not gonna go anywhere remotely close to that. But in university, if you're interested in this, you can take the high level courses and you see how deep the rabbit hole goes. Anyways, let's look at this question. Question 1, they want us to find x. I'm going to ask you, relative to x, which sides are given? So we know something is 60, something is 65, something is 25. But now you want to look from the perspective of x. Is 60, again, you've got to look at it from x's perspective. Is 60 the adjacent or is it the opposite?
Opposite.
Yes, 60 is the opposite. What about 25?
It's the adjacent.
Yeah. What about 65?
The hypotenuse.
Right, the hypotenuse. So depending on which angle you look from, the O and the A might be different. H will always be the same, right? Similar to a squared plus b squared equals c squared. The hypotenuse will always be the longest side, but O and A can change, okay? Depending on the perspective that you use. And now they want us to find the angle X. What can we use? SOH CAH TOA. Do we sine, cosine, or tan?
Do you use sine?
So we're trying to find the angle x, right? We can use all three of them. Here, let me set this up for you. We're trying to find angle x, yeah? We could either do sine of x is equals to opposite over the hypotenuse. You see this one?
Mm-hmm.
Or we can do cos of x. Tell me, cos of x equals what over what? It's a over h,
A
right?
over the
Yeah, so it's 25 over 65, right? Or
Mm-hmm.
you can use tan of x. And that'll be what? O over a, right? Because in this case,
Mm-hmm.
all three sides were given. That's why we can use all three ratios. Why don't you plug this in your calculator? Find me x. And again, how do you find x here? I forgot how your calculator works, but first step one, do 60 over 65 and then do sine inverse. So this is like 0.923, okay? Do sine inverse of this. So you first want to type in 0.923 and then do second function sine.
67.36.
All right, we're just gonna call it 67, okay? Now try doing this one, cos inverse of 0.385. So first type 0.385 and then do second function cos.
67.35.
Yeah, exactly. Well, now try doing tan inverse of 2.4. First type 2.4 in because 2.4 is that, and then do second function tan.
It's 67.38.
Yeah, see, all of them will be the same, right? They're all 67 degrees. So it doesn't matter which ratio you use in this question because they've given you all three sides.
Mm-hmm.
So x is 67. How do we find y? Y is the angle on the bottom there.
Wouldn't it be like 23?
Yes, how did you do that?
Because like all of it adds up to 180.
Yeah, exactly. That's the perfect way of doing this. We could always do sine y equals yada over yada, but that is not the best way to go about it, right? That does work, but the best way is 100% to do 180 minus this minus that. Cool?
Mm-hmm.
So look at this question. It says identify the primary trig ratios. And why is it saying primary? What's the other? What comes after primary?
Secondary.
Right. We're not going to do secondary, but would you like to see what they could possibly look like? Here, let me tell you what they are. This is just to, bring out your curiosity. We have sine, we have cosine, and we have tan, right?
Mm-hmm.
Secondary just means 1 over sine. You just flip it upside down. And that gives us a new function. It's called cosecant, written as CSC. Same thing with cosine. We flip this 1 over cosine, and that gives us something called the sec function. Tan, we flip it upside down. It gives us the cot function. Okay, and these are called a secondary. We won't do them here, but they do exist. I'll see if they come up. I guess we'll have to do them. What do you think cosecant of x looks like? Here, let me show you. because this is also very interesting. We know sine of x looks like, not nx, just x. There you go. Sine of x looks like that. Cosecant x is 1 over sine, okay? You just flip sine upside down.
Mhm.
What do you think it looks like? Given that cosecant is 1 over sine, what do you think cosecant looks like graphically? And this is the sine function in red right here.
Would you just like flip the red thing?
Yeah, you'd expect that, right? But no, it looks something super wacky. Boom, the one in blue.
What?
Yes. Again, and this has to do with the breaks in the graph, right? Because if you get sine of 0 is 0, okay? And
Mhm.
that means cosecant does not exist at 0 degrees because you'd be dividing by 0. What that means is that there's an invisible wall every 180 degrees. Well, if I can draw straight lines, you see it right here? There's an invisible wall because at that point, the value of the sine is a 0.
Uh-huh.
You see sine is 0 right here in the red, sine is 0 there, the y value is 0 there, the y value is 0 there, the y value is 0 there. So at that point, cosecant function ceases to exist because we're dividing by 0. And whenever you divide by 0, there's a break in the graph. There's like it hits an invisible barrier, and it's right here. When we're doing this in maths, we actually show them, but the calculators don't. This is a graphical calculator. It doesn't show us, but there are invisible walls, infinite of them. Okay, and that
Mhm.
is the secondary trig ratio cosecant of x. Same thing with the sine, cosine. The primary ratio is called cosine of x, yeah? And the secondary ratio is called sec. It's also going to look very similar. It's going to be a bunch of x squares, you know, like what the curves, upside down curves. Boom. And now this one's very interesting. You remember tan was already wacky as it was. What do you think 1 over tan looks like? Which is a secondary function called cotangent.
I have no clue.
All right, this one, funnily enough, this one is it doesn't look very different. It's just,
Really?
yeah, it's just flipped. It's like a mirror image.
Oh, okay.
Looks kind of beautiful, doesn't it? Like in a sense. And by the way, there is something called Desmos arts. Here, let me show you. You see, these are all curves, right?
Mhm.
Do you find this kind of like beautiful, like in a like, I don't know, in a mundane sense of way? What you can do is you can take this up to the next level. Here, let me show you what people have done. Someone drew this. It's gonna take a while to load because there's like 3,000 curves. You see this little fox?
Mhm.
Someone literally drew this using a bunch of curves. Thousands of them though,
Like just curves?
with just curves, thousands of them. You see all these? They all represent
Uh-huh.
curves. Yeah,
They
just
used
curve.
math to draw?
Yes. They use math to draw this on a graphical calculator. Okay. See, we had
Uh-huh.
something like this, right? Yeah, you can kind of chop it off. You can just use this from this to this. You can give it like which part you want to use. You can use that to draw art out of it. Look at this. It's very interesting, right? Probably took like hours or days or weeks, but it is possible to
It
come
looks
up.
cool though.
It does look cool. Yeah, that's the point, right? It looks really cool. Yeah. So you can take this to the next level. Anyways, let's do this question before I let you go. So this one is just, again, we don't care about the secondary. Okay, don't worry about that. I just wanted to show you that they do exist. So this one, does sine, cosine, or let me just write SOH CAH TOA because it'll be easier. SOH CAH TOA. Looking at it from this angle's perspective, 50 over 54, what is that? Is that sine, cosine, or tangent?
Um,
Again, we can label the sides, right? Opposite would be this. hypotenuse is always the longest side, and this is A, right? So if you see 50 over 54 is what? A over H, yeah?
Mm-hmm.
So which one is it? Sine, cos, or tan?
Cos.
Right, so cos of theta is equals to 50 over 54. Easy as that. What about 20 over 50?
Is it tan?
It is tan, it's O over A, right? So tan theta, again, we don't know what theta is. We can find it though by doing tan inverse of 20 over 50. And finally, the last one must be sine, right?
Mm-hmm.
There you go. Easy as that. That makes sense?
Uh-huh.
The trig is kind of interesting. So far what we've done is we've only done it for right angle triangles, right? But you could do it for any triangle, and we'll do that if we get to it. I mean, I don't know if it's going to come in this book, but if we get to it, we'll do it next time. But and the math there is going to be a little bit more complicated though. Trig applies to any triangle, doesn't necessarily have to be right angled. Right angled is the easiest to do because we can use SOH CAH TOA, but SOH CAH TOA breaks when we're using triangles that are not right angles, because what does the H represent in SOH CAH TOA? What is
The
the
hypotenuse.
right hypotenuse? What is the definition of a hypotenuse? It is the longest side in a triangle, or the side that's opposite to the right angle, right?
Mm-hmm.
And now when you look at a triangle that has no right angle, what is H? H does not exist. So SOH CAH TOA does not exist. We're going to have to use different methods to deal with problems that involve a non-right angle triangle. Okay, it's a little bit different, but yeah,
Mm-hmm.
we'll pick it up next time.
Okay, thank
All right,
you.
all right, take care now. Bye bye.